Ladies and gentlemen, welcome to another tutorial about the new functionality for commands, command blocks, map making, that good stuff in Minecraft 1.12. My name is slicedlime, and last time we went through all of the things that have changed that you have to update to make a map work in Minecraft 1.12. But there are many more things to it. There are the new advancements and the entire complex system behind that. There's the new way the chain command blocks execute and all of the new fancy things that enables. But this time we're going to talk about what is arguably the most important change in this version and the one that is going to completely change how you make maps and command block systems in this version of Minecraft. I'm talking about functions. So, what is a function? Well, there is a new command in town, and that command is called /function. And if we just run that to get the usage information up, we see that it is function followed by a name and then optionally if selector or unless selector. So we'll deal with that one thing at a time, the first thing being the name. So if we run function again and then try to tab complete, I get absolutely nothing. Well, that's too bad, we have no functions. So let's create one, and that requires leaving Minecraft and heading to an external text editor, because a function, as it turns out, is a file of text. Okay, so we are staring at a blank document in our text editor now. How do we make this into a function? Well, it turns out that a function can have three different things on a line. The first thing it can have is a command. You know those from before, and they have to be written in a certain way in a function file. That certain way is you write them without any preceding slash. The slash is simply meant to distinguish a command in chat, and so in a function file you leave out the slash. So we could say hi in our function here. That is a valid function. We could now save and run this from the game. But we'll get to that. Let's talk about the other things that you can put in a function file. The second thing you can put in a function file is a blank line. That's perfectly fine. If you want to space things out, get better overview of your commands, that's also fine. There's one more thing you can put into a function though, and that is yet another tool to organize your commands. That last thing is a comment. A comment starts with a hash sign, and then whatever text you want until the end of the line. And then of course you can have whatever commands you want in here. Alright then, so we need to save this text file to get it into the game. Now the question is, where do we save this text file? Well, the first thing you need to do is you need to find your Minecraft folder. Where that is can depend on your profiles, where the launchers put it, and so on, but most commonly they're under your user folder, under a folder called app data, and then roaming, and then .minecraft. This will be different on different versions of the game, so on a Mac, this will be a different directory, for instance. I'll put some help down in the description of the video if you don't know where to find your Minecraft folder. Now with that said, you then need to go into your saves, and then the world folder for the world that you were playing in. In my case, that's this world, functions tutorial, and we are going to head into the data folder that will already exist, and then functions. Now we end up in a blank folder. Well, we're not quite ready yet. In here, we need to do one more thing. And to understand what that means, you need to understand that a function name has two separate parts. One is a namespace, and the one is your function name. The namespace is represented in here as its own directory. You can think of the namespace as your own little box to put functions in, and as long as you have your own little box, you are guaranteed that you will never clash with anybody else's function, even if you have a function called doThings, and somebody else has a function called doThings, and you put both of those functions into the same world, they will never clash because they have a different namespace. And that namespace is a folder that we'll create right here. So for our purposes, we could have a lime folder that will be our namespace. So the namespace is now lime, and we can now save our function. The function name can be whatever you want. So let's name ours doThings, and then it has to have a certain extension, which is .mcfunction. With all that done, we can save this function and go back to the game. Well, now we're back in game, and we spent so long time writing our function that day has turned to night. That doesn't matter though. Now we should be able to use the function command, right? Well, I can still not autocomplete anything here. That is because the game only loads these functions when you log into a world or start up a server. So when you click on the world from your world screen in single player, or when you start it on a server, that's when the game loads the functions. So do we need to restart every time to get our functions in? Well, no. It turns out there's another handy command, /reload. If you do that, you get this message. Successfully reloaded loot tables, advancements, and functions. So now we have reloaded our functions, we can do /function and autocomplete lime::do things. You can see here the namespace, which is lime, and then a colon, and then the name of the function, do things. Now we put our function directly into the lime folder, but there's nothing preventing you from having subfolders here. And the way that looks in-game is like this. You would have sub/do things if you put do things in the lime/sub folder. Now let's run lime do things. You see, I say hi, then I say more commands, and the whole thing results in executed 2 commands from function lime::do things. Alright, so exactly what happens when we run a function? Well, the game will start at the top of the function and run the commands one at a time until it reaches the bottom. It's as simple as that. And the commands will all run in the context that the function was run. That means, for instance, that since I ran this function, then I said hi, and I said more commands. Now, let's run this function from somebody else. Let's execute at e type equals not player c equals 1. So let's grab the closest whatever that isn't a player and execute this function from that thing. Oh, our friend the rabbit around here somewhere said hi and more commands. And then the rabbit executed 2 commands from the function lime::do things. So inside of the function, the executing entity will stay the same. And this is actually true over the entire function call. The executing entity and the position that the commands run are all locked in at the start of the function, and the rest of the commands in the function act as one unit. They all run in the exact same context. This can be extremely useful, and for the programmers out there, it makes the functions act like actual functions in a programming language. This also means one more thing. If we go back to our doThings function, and instead of saying hi, we just say @s. Save that, run /reload as the sun rises, and then run /function lime::do things. We will see that now I am saying my own name. That is because Minecraft 1.12 adds not only functions, but also a new selector of mine called @s. This new selector can only select the entity that is executing the commands. Of course, you can also use selector arguments to restrict the selection further, but this has the benefit of being vastly more efficient than the other selectors, even with the restricting arguments. Turns out that these 2 things are very useful in combination. If you use @s inside of our function, we can now combine that with running the function on many things. So if, for instance, we do execute @e c equals 10, function lime::do things, then we get this. Skeleton says skeleton, bat says bat, creeper says creeper, skeleton says skeleton, rabbit says rabbit, bat says bat, I say my name, and so on. So here we see we managed to execute a function on 10 different things, and they all knew that they were the one executing the function. This is incredibly powerful, because we can run complex calculations, tagging operations, and more on multiple entities without having to do a lot of bookkeeping work or duplicating commands or waiting a tick. These are completely new capacities that didn't exist at all in Minecraft 1.11. Now remember how I said that there were 2 optional things that you could put on the end of a function call. Let's bring up that usage again. If selector and unless selector. So we can do /function lime::do things, and then if and some selector here. What this means is that the function will only run if that entity exists. If this selector selects nothing, then the function will not run. So for instance, if we test for a rabbit within a radius of 10, and this of course will select the rabbits within a radius of 10 from the point of execution of the command, which is right where I am standing. So let's run that command. Skipped execution of function lime::do things. Since there were no rabbits within a radius of 10 from me, the function did not run. However, if I increase this to 25, I say my name because the function is still say at s, and you can see that one command was executed from lime to things. Note that this is different from executing the function from this rabbit. If I had done execute at e-type equals rabbit r equals 25, then the function would have run using the rabbit as the execution point. And not only that, there may have been more than one rabbit, so the function might have run several times. The other keyword, unless, is simply the opposite. The function runs when the selector finds nothing and will not run when the selector finds something. This means that you can test for the existence of a certain entity, including tags, scoreboards, position in the world, whatever you like, and call a function based on that information without having to execute from that thing's position. However, if you do want to execute from that thing's position, then you can simply do /execute with a function command on it. To further explain the power of functions, we're going to need some more tools. Let's add a scoreboard objective that we can call test of the type dummy. Let's also set that as our sidebar display slot so we can see what's going on. Now, let's head on to our editor and make a new function. Alright, we are back in our text editor, and this one is going to be a little bit more complex. So, let's start by writing down a comment of what this function is supposed to do. We are going to give all rabbits a unique score in the test scoreboard. Let's save this one right away, and it's going to be called rabbits, and it's going to be in the lime namespace still, so it's going to be in the lime folder, and we'll name it rabbits.mc function. That'll be important later when we go to call it, but for now let's keep working on our function. To start off with, we don't have any scores for the rabbits, so let's do scoreboard players add at e-type equals rabbit test 0. So at this point they don't have unique IDs, but at least they are all on the scoreboard, so we can all start doing work on them. Now, giving all of the rabbits a unique ID is a fairly tall order. It's a much more difficult thing than it might seem, and it was actually impossible, or well, at least impossible to do with a limited amount of command blocks in the previous version of Minecraft. However, in this version we can do it with one single function call. So that's pretty cool, isn't it? But it is a bit of a tricky concept, so let's maybe start by a simpler task. And that simpler task is going to be give one rabbit a unique ID. So, let's select one rabbit to start off with then. Scoreboard layers tag at R. So let's just pick a random rabbit. And let's pick one that has a score in the test scoreboard that is at most 0. So pick a rabbit out of the ones that don't have a unique ID yet and add a tag called selected to that one. Alright, so we pick a rabbit at random. Now how do we give it a unique ID? Well, we can start by doing a scoreboard players operation at e tag equals selected. In the test scoreboard, we want the maximum value of anything in the test scoreboard. So after we've done that, we know that the score in the test scoreboard of the selected rabbit matches the maximum score in the scoreboard this far. Well, if we have the maximum score, then we can simply add 1 to get a unique score, right? So scoreboard players add at e tag equals selected test 1. Alright, so that wasn't too bad. We have a rabbit and it has a unique score in the test scoreboard. But it still has the selected tag, so maybe get rid of that, right? Scoreboard players tag at e tag equals selected, remove selected. Right, so now we have a function that gives a rabbit a unique ID. But there are plenty of more rabbits, or at least potentially more rabbits. So how do we do this again? How do we make this happen until we have no rabbits left? Well, here's where the power of functions really shine, because we can call a function that gives a rabbit a unique ID in here. So we can run a function command. And wouldn't you know, we happen to have this function that gives a rabbit a unique test score. So let's run that. lime:_rabbits. So this function is now going to add a unique test score to a rabbit at random, and then it's calling to call the lime rabbits function that gives a unique test score to a rabbit at random, and then call the lime rabbits function which gives a unique test score to a you see where this is going. It's never going to end. That's a problem. Or, well, it's going to end, but only once it hits a certain limit. We'll speak more about that limit later. In order to make this not go on forever, or at least potentially forever, we'll add an if here. Remember how I said you could use if to only run a function if a certain condition is met. That condition being a selector exists. So we can test whether we have anything that is of type equals rabbit and score underscore test equals 0, which means that do we have a rabbit out there that still doesn't have its ID? Well, if we do, well then let's run the function over again. This line represents a concept known in computer science as recursion. Recursion can be used to implement any kind of looping that you want, including testing things for all IDs going on until a certain condition is met or going while a certain condition holds. All of those things can be done with functions. Now let's head on into the game again and test this thing out before we discuss the restrictions and limits. We are back in the game, and let's start by using F3 plus D to clear out our chat log of all the old junk, and then do /reload to get the new function into the game. Now we can do /function and tab complete, and I only get lime : because now there's more than one option here. And if I hit tab again, we see that we now have do things and rabbits. So if I run this rabbits function, and remember, I still have the test scoreboard set as my sidebar objective display. So we should see things happen. Alright, I got a whole bunch of scores, so apparently we have 103 different rabbits in the world. That's pretty cool, right? And we can see executed 720 commands from function lime : rabbits in one go. And we just got scores for all the rabbits in the world. That's pretty cool. And before you could do the same technique, but you have to do one per tick. So in the previous version of Minecraft, the reasonable way to do this would have been to give one unique ID or one unique score per tick, which would mean that this would have taken more than 5 seconds to do, because there's 20 ticks per second, so 100 is 5 seconds. So that's actually pretty noteworthy. Let's get rid of this scoreboard objective set display sidebar. And let's talk about more things. Now, there are 2 game rules that relate to this. There's one that relates to how many commands can run from any single invocation. Now, what is an invocation? Well, for instance, if I run the function command from the command line, that is one command invocation. If an impulse command block gets triggered and runs a command, and then triggers a bunch of chain command blocks, that's one invocation. And if a repeating command block triggers on its tick, and runs a bunch of chain command blocks, that's also one invocation. Now, there's a limit to how many commands can run on one of those invocations. That is controlled by a game rule called max command chain length. The default value for this is 65,536, so you can get a fair amount of commands running, but you can also increase that if you're doing a special map that requires a lot of recursion. Or you can decrease it if you're having performance problems, but I would suggest that you fix your loops instead. This is simply there to make sure that you don't, by accident, lock up the game by causing it to do millions and millions of commands within one same tick. There's one more interesting function-related game rule. That game rule is called game loop function. This game rule is a function name, and the special thing with this game rule is that the function you set it to will get automatically run once every tick. So if we set the doThing function, well, nothing happens. Why is that? Well, that is because our doThings function contains only one command, and that is say @s. Well, @s selects, as you might recall, the entity that runs the command. However, there is no entity in this case. The thing is being run by the game, so that doesn't work. Instead, let's head back into our editor and make a quick new function to demonstrate. We are once again in our editor, and we're going to make a very quick function. It's going to simply be one single command. So we're going to do execute at A, where they are, detect the block below being sand of any type. And if that's the case, we're going to say standing on sand. Let's save this as loop.mc function. And here we are back in Minecraft. Let's do reload, not recipe, to get that function into the game. Game rule, game loop function, lime, :loop. So nothing appears to happen. Let's go stand on some sand. Standing on sand. And it happens every tick. You see my chat is getting spammed with standing on sand. That is pretty powerful indeed. One thing I've found especially nice is to use the game loop function to represent the current state of a minigame. So you could have a different game loop function depending on which state you're in. If you're in the lobby, if you're waiting for players to select something, or if you're in the actual game rounds. Remember, the game loop function is just a game rule. It can be switched out at any point during the game. Now, there's one more limitation that can be important to mention before we end off here, and that is conditions. Now, with chain command blocks, you can simply put one to be conditional, and you can test for a condition in the previous block, and there you go. Not so much for functions, because, well, there isn't really any way to have a conditional command. What you'll have to do is use the /stats command to get the result of the command that you're testing into a scoreboard for a certain entity. And then you can use that score as a selector argument to test for it in an actual selector. So that gets us to the end of the tutorial about functions in Minecraft 1.12. Of course, this only scratches the surface of what you are able to do with them, but at least it explains all of the basic components to working with functions. And trust me, after converting some of my maps to using functions, they are so much easier to work with. It is just so much easier to get an overview of a file that contains comments and a bunch of commands than it is to get an overview of a long line of chain command blocks. And that, my friends, was all for this time. My name is slicedlime. Thank you for watching. I hope you enjoyed it, and take care.